Okay, we're going to start with chapter 4, that we're on 4.1 inverse functions. And we're going to start by talking about one-to-one functions. And the way we determine if a function is one-to-one is if a horizontal line passes through the function at most once. So if it goes more than once, then it's not one-to-one. So for example, if I graph this is already in slope-intercept form, so I know my y-intercept is 0, 4, and my slope is 3. So if I'm just going to sketch this here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I have 0, 4. My slope is 3. So it's going to be like this. And, oops, wrong way. It's going to be like this. Okay, so this is going to be my function. And then I'm going to draw a horizontal line through it to determine if it passes through the function at more than one point. And if I draw a horizontal line through this is my horizontal line. It only passes through the function at one point. That means it's one-to-one. Now remember, we had the vertical line test previously, and if a vertical line passes through it only once, that means it's a function. But if a horizontal line passes through it, then it's a one-to-one function. Okay, so let's look at the next one. We've got, this is going to be a quadratic because it's x squared, so we know we're going to have a parabola. And it's at -5 is my y-intercept. I know that because if I plug in 0 for x, I get -5. So 0, -5 is my y-intercept. So I'm going to do this. 1, 2, 3, 4. 1, 2, 4. 1, 2, 3, 4, 5. And it's going to go up 1 here. Okay. So this is coming up through here and through here. And now if I draw a horizontal line through this, it actually passes through this function in 2 places. So this is not one-to-one. Okay. Now, an inverse function is a line that reflects over the line y equals x. Okay, if it reflects over the line y equals x, it's an inverse function. And if it's a one-to-one function, and its ordered pairs are a, b, then the inverse function, the ordered pairs are going to flip if it's one-to-one. Okay, it only works if you have a one-to-one function. So we're going to use the graphs given. We're going to sketch the original graph, the inverse, and then we're going to find the domain and range of both. So I'm going to start with these points on the line at 0, -2, and I did that wrong again. Wish you were here for me to give you candy. 0, -2, and 2, 0. Okay, so this is my original line. Okay, and I'm reflecting it over the line y equals x, which goes through the origin at a slope of 1. Okay, so I want to reflect over that. So if I'm going to do that, then for my inverse, my ordered pairs are going to be the opposites. So 0, -2 is going to become -2, 0, and 2, 0 is going to become 0, 2. So I have -2, 0, and 0, 2. And so my inverse is here. And if you look at those, they reflect, yeah, it's a little off because I wasn't paying it. You have to be really careful to graph them really precisely. Okay, there we go. And if you look, if you think of the dotted line, the y equals x, as like a mirror, and see how it reflects evenly over that mirror. Okay, so we're going to try this one. This one, my original line is -4, 0, 0, 2, and over 4 and up 4. Okay, so this is my original line. Okay, I'm reflecting over y equals x, so I'm going to draw the dotted line just so we can see where what it's reflecting over y equals x. right? And for my inverse, my ordered pairs are going to be the opposite. So I'm going to have 0, -4. Okay, I'm just flipping those around. 2, 0, and 4, 4. So I have 0, -4, 2, 0, and 4, 4. And so the inverse goes like this. And again, if you think of that dotted line as being a mirror, okay, they should be a reflection of each other in the mirror. Okay, so in order to find an inverses function, we switch x and y, and then we solve for y. Okay, this is the way that you figure out what the inverse is without having to graph it. So to find the inverse of this function, first I rewrite this as y equals 2x plus 5. Then I'm going to change my x and my y. So now this is x equals 2y plus 5. And now I'm going to solve for y. So I'm going to subtract 5 from both sides. So I have x minus 5 equals 2y. And then I'm going to divide by 2. So what I have is y equals, and you separate this into x over 2 and -5 over 2. So this is 1/2 x minus 5/2. Right? So what I did is I took x over 2 minus 5 over 2. Okay, and just pulled the 1/2 out in front. And that means that my inverse function, and the way we write that is f to the -1 of x, the inverse of x, equals 1/2 x minus 5/2. Now that would be your answer for the inverse function that we started with. Okay, let's try a couple more. All right. Remember, f of x and y are basically the same concept. Okay, the output that you get when you put in the input in for x. And we're going to switch our x and our y. So this is x equals 4/5 y minus 3. And I'm going to solve for y. So I'm going to add 3 to both sides. So I have x plus 3 equals 4/5 y. I'm going to multiply both sides by 5. And I have 5x plus 15 equals, the 5's will cancel here, so I have 4y. And then I'm going to divide both sides by 4. Now if you multiply both sides by 5/4, it's going to do the same thing. So this is 5x over 4 plus 15 over 4 equals y. So the inverse function of x is going to be 5/4 x plus 15/4. Okay, we're going to try one more for this first day of this. I'm going to, remember this is like y, so I'm going to trade x and y, so I have x equals y to the 3rd minus 6. Again, we're trying to isolate y to get y by itself, so I'm going to add 6 to both sides. So I have x plus 6 equals y to the 3rd. And the way we undo a cube is we take the cube root of both sides. So I have the cube root of x plus 6 equals y. So the inverse function of the given function is the cube root of x plus 6. And that's all we have for this session.